Okay, so this video is about free radical substitution, and this is the first type of organic mechanism that we're going to look at. So an organic mechanism is the route by which you go from one organic molecule, in this case methane, okay, and convert it into another organic molecule by reacting it with something. So we can convert methane into chloromethane by reacting it with chlorine. The name of the mechanism tells you how that transformation occurs. So I'll first explain substitution. So what's going to happen in this reaction is that one of the hydrogens on the methane is going to be substituted for chlorine. Okay, so we can see in the product here, chloromethane, the chlorine has taken the place of the hydrogens. Okay, so in a substitution, one atom or group of atoms replaces another in the molecule. Free radical is the mechanism by which it occurs. So this reaction involves a halogen and UV light. And UV light will break down the chlorine, producing a radical, and it is the radical that will react with the methane. So I'm going to now explain how, in more detail, this mechanism occurs. So free radical substitution is a reaction that alkanes undergo. Now, what we do need to understand is that alkanes, of all the families of hydrocarbons, okay, are unreactive, okay? And the reason for this is because of the strength of the carbon-carbon and the carbon-hydrogen bonds. They have a high enthalpy, and so they are difficult to break. And the molecule is also non-polar, okay? So what this means is that nothing will be attracted to the molecule in order for substitution to occur by a different mechanism. Okay, so alkanes are unreactive because of the strength of the bonds in the molecules and because they are non-polar. So the only type of reaction they will undergo is free radical substitution. Okay, so we need to remember some information about free radicals. Okay, so a radical is formed when a bond is broken by homolytic fission. Okay, what this means is that one of the electrons, okay, in the covalent bond will go to each of the atoms in the molecule, okay? And this will produce us two radicals. Radicals are highly reactive species because they have an unpaired electron, okay? So alkanes are very unreactive, and the only way we can get them to react, okay, and transform them into another molecule is to react them with a free radical, which is highly reactive because of the unpaired electron. So this mechanism, free radical substitution of an alkane, involves 3 steps. Okay, so the 3 steps are initiation, propagation, and termination. Okay, I'm going to be going through the example shown above of methane with chlorine in the presence of UV light. What I will ask you to do after you've watched this video is I'm going to ask you to answer some questions, and you're going to write out the steps, and you're just going to substitute the chlorine for bromine. Okay, so you're going to watch this video, try to understand what happens in each of the steps, and then you're going to apply that same reaction, but we're going to switch the halogen it reacts with to bromine. okay? So in free radical substitution mechanisms, the initiation step will always be the same, okay? And we need to produce the radical. So when chlorine, okay, when we shine UV light on chlorine, it will break the bond between the chlorine molecules by homolytic fission, and it will produce two radicals. If you're asked to show this step by the means of an equation, okay, you don't need to show the arrows, okay, but it won't do any harm if you do, okay. So the initiation step is always what the production of the free radical by shining UV light on the halogen molecule. The propagation step is what happens when the radical reacts with the methane. So we've formed the chlorine radical, it's highly reactive, and it will react with the methane. What will happen is that you've now formed a methyl radical, okay? So you remove the chlorine radical will remove a hydrogen from the methane, producing the methyl radical and forming hydrochloric acid. This radical, the methyl radical, will then go on to react with a chlorine molecule, okay? And this will make us the chloromethane, and the result of the reaction is that we'll reform the chlorine radical. So this is one way we can recognize a propagation step. The reaction of the radical with the hydrocarbon will produce a radical and hydrochloric acid. That radical will then go on to react with the halogen molecule, okay? And we will always reform the radical that initiated the propagation steps, okay? So when a radical reacts with a molecule, okay, we always form another radical. This propagation step, okay, it results in a chain reaction. So what I'd like you to think of is that the radicals are really reactive and they're a bit of a loose cannon, okay? They're so reactive that they will react with any molecule that's nearby, okay? And in this propagation step, you reform the radical. So that can now go on to react with another methane. So one chlorine radical can react with millions of methane molecules, okay, to form the product, okay? So the propagation steps result in chain reactions, okay, where one radical reacts with many other molecules. Now, the final step is the termination step, and this occurs less often because the termination step always occurs between two radicals, and the likelihood of two radicals meeting is low. But when they do, two radicals react, okay, to reform the chlorine. Now, the chlorine radical is not the only radical within the mixture. As you can see in the propagation step, okay, a methyl radical could also react with a chlorine radical. And then finally, the methyl radical could also react with another methyl radical, which would produce you ethane. Okay, so that's the initiation, propagation, and termination steps. It's probably worth pausing the video and maybe going back to what happens in the initiation step, the propagation, and the termination. Okay. Now, what I'm going to go through next is that free radical substitution, as you can see by the termination step, will produce a range of products, okay? So this here is the overall equation for the reaction, but chloromethane is not the only product. There will be a mixture, okay, alongside the hydrochloric acid. So how can we form other products other than what's shown here? Okay, well, it's all to do with the propagation step, okay? So the other propagation steps, okay, which will result in different products, okay, will be when the chloromethane reacts with a chlorine radical. So what you need to see here is that this chlorine is going to react with one of the hydrogens, okay, and you're going to form hydrochloric acid again. And you'll produce another radical, but this time it will be CH2Cl. Okay, so we've removed a hydrogen from the chloromethane, okay, because of the chlorine radical reacting with it, forming hydrochloric acid. In the propagation step, the radical will then go on to react with another chlorine molecule, okay, and then we will form dichloromethane, okay, and we'll reform the chlorine radical, okay. So this is important if you're asked about other products, okay, in the reaction mixture. So I'm going to finish the video there. It's quite a lot to take in, and I suggest that you do some reading to reinforce your understanding.